Now let's understand what a truth table is, okay? A truth table is something that gives me the relationship between the truth values of a compound proposition and its associated primitive propositions. Okay, so I'm going to define it as truth table that displays relationship between truth values of a compound proposition and its associated primitive propositions. Okay, associated primitive associations. We are going to understand what this is in a while, okay? So let's suppose that I have a primitive proposition P, okay, and I would like to understand what is the truth values of a compound proposition created with the help of negation. Okay, so it happens like this. I create a table, okay. It is going to have a primitive proposition which is P, okay. It is going to have a compound proposition which is my negation of P, and I am going to fill in the truth values for primitive proposition. So what are the truth values? There are only two truth values. It's either true or false, okay. So whenever I have a true value, I represent it with a 1. Whenever I have a false value, I represent it with a 0, okay. So my P can take two values, a true value or a false value, okay. Similarly, my negation of P in that case would be negation of true, which is false, and here it would be negation of false, which is true, okay. So this is your truth table for negation, okay. So this is truth table for negation. Okay, similarly we can have truth tables for conjunction, disjunction, implication and biconditional. Now let's look at them as well. Okay, so let's suppose I have two propositions P and Q. From this I create a conjunction, okay. Let's call this P and Q. I create a disjunction, let's call it P or Q. I create a implication, it is going to be something like this, and I create a biconditional, it's going to be something like this. So we are going to now find out the truth table for each of these compound propositions, okay, all of these, okay. So let's see how. Now since I have two propositions over here, this Q can take a true value or it can take a false value, okay. Now similarly P also can take a true value and a false value. So together both of these can take a combination of 4 values, okay. So it would be something like this: true, false, and it's going to be something like true, true, false, false, okay. So in total I have 4 values for P and Q. When both P and Q are true, when only P is true, when only Q is true, and when none of them is true, okay. So since we have established a convention in which we say that we are going to represent true as 1. So let's do that over here as well. So what I'm going to do is I'm going to write it like this. I'm going to say this is 1 0 1 0 and this is 1 1 0 0. Now P and Q is true when both P and Q are individually true. So here, as I can see, both P and Q are individually true. Therefore, P and Q compound statement is true. Now, all other cases, it is going to be false. Okay. Similarly, P or Q, where or is used in an inclusive sense, is true whenever at least one of P or Q is true. So here both P and Q is true, therefore P or Q is going to be true. Here P is true, therefore again this compound statement is going to be true. Here Q is true, therefore this compound statement is going to be true. Now here both the statements are false, therefore the compound statement or P disjunction Q is going to be false. Okay. Now an implication is false whenever you have P as true and Q as false. Okay. Let's just take an example to understand what is happening. Okay. We have an implication over here. So my implication is, if Jim is studying in his room, then Jim will pass the exam tomorrow. Okay. Now let us suppose my P is true. Okay. So I'm saying this is true, which means Jim is studying in his room. Okay. And I'm saying Q is false. Okay. Q is false means Jim will not pass the exam tomorrow. Okay, so I am saying if Jim is studying, then he will pass the exam. But Jim has studied, but he has failed the exam. Therefore, this proposition is false. Okay, therefore this proposition is not correct. Okay, hence I say implication is false when P is true or when hypothesis is true and conclusion is false. Okay, so that was your implication truth table. So we are going to put it down here. So when P is true and Q is false, which means this particular scenario, in that case your implication is going to be false, and in all other cases it is true. Okay, so this was your implication. Now we are going to take a look at biconditional. My biconditional statement is true whenever both P and Q are both either true or both either false. So in this case, when they are both true, my biconditional is true, and in this case when they are both false, my biconditional is true. In all other cases, my biconditional statement is false.